Hello, everyone. Thank you for joining. I'll just go over the agenda real quick and then we'll get started. So, we'll start with introductions and then we'll go through a little bit of a case study. We'll talk about Industry 4.0 solutions, talk about using multiple sensor sites, how to prove out your ROI. Then we'll get into integration strategies. And then at the end, we have time reserved for a Q&A session. So, Marwan, if you'd like to go ahead and introduce yourself.
Yes, sure. Hi, everyone. So Marwan, my training, or I would say I'm a mechanical engineer by training. I used to work in the steel industry before, where I had a lot of time solving challenging maintenance problems at the time. It was a good experience to learn how complex equipment works. Then after that, I joined Amazon, where I focused mostly on all the predictive maintenance strategy for Amazon across EU and APAC at the time. Later on, after doing all of this, I joined AWS, where I worked on predictive maintenance and Industry 4.0 services for AWS. So it was a combination of cloud services, AI, ML, in addition to industry. So really quite interesting. And after that, I went and created my own company where I became an AWS partner, still doing the same thing. So focusing on Industry 4.0 solutions driven with AI, ML, but for industry, anything that is manufacturing or otherwise anything that is industry. So trying to combine both languages from maintenance people, industry, and at the same time from IT and cloud. That's me.
Awesome, Marwan. Really appreciate you being here today and doing this webinar with us. My name is Tamian
Yes, sir.
Taylor. My background is in computer engineering, and I've got 10 plus years working with infrared and remote sensing technologies. Similar to Marwan, I started in heavy industrial applications, oil and gas, steel plants, things like that. And the majority of my career have done infrastructure condition assessments and then R&D applications for anything infrared related, whether it be automotive, manufacturing, medical. And then Marwan, if you wanted to go ahead and present this first slide.
Yeah, absolutely. I think it's always a good, I would say, intro to start discussing about these subjects. So the way the market is divided today, and a lot of studies, the way they show it is that if you look at all the machines globally in the whole planet, regardless of the manufacturer or regardless of the industry that they're in, you will have this kind of division where 60% of all machines will run to failure, not because it's a strategy or whatever, but a lot of times maintenance teams are overloaded. You try to focus on your critical equipment, so a lot of machines will run to failure. And again, you will have also disparities between the regions. Like developing countries will work in a certain way, developed countries will also work a bit differently. 30% will be planned maintenance, regardless of the type of planning, calendar based or cycle based or whatever. You will have a certain control over consumables and changes that you have to do over time, but that's it. And then you will go a bit further in the market and you will have around 10% of all machines globally that will have a proper CBM strategy. So you will be doing condition-based monitoring, in some cases condition-based maintenance, which is really only acting when you have a change of condition. And that usually, if you look at developed countries like Europe or North America, where you are, you will have certain machines in each plant that where we focus at, and then the rest is either planned maintenance and run to failure. And when you go really high end, you will start having prognosis or prescriptive. That's when you go really high on condition-based monitoring. You start having a lot more data, sorry, condition-based maintenance, and you have a lot more data. You have either an expert that is analyzing the data and only make launching or triggering the maintenance when the data shows us that we need it. Prescriptive, and we start using ML, machine learning. So we start automating that thinking process and that decision-making process. And so it's always actually quite interesting to start with this, but it just gives you an idea that actually there's a huge still possibility to grow in the market and also to do a lot more in the business or in the industry.
Wonderful introduction to condition-based monitoring and how the breakdown of equipment is, those maintenance strategies on that equipment and how that's broken down. So let's talk a little bit about how you ended up at Amazon and how you found your way into reliability and maintenance engineering.
Yeah, sure. So, as I would say, hinted to it earlier, when I used to start to work in the steel industry, you and I, myself, we know each other. We've worked in heavy industry, so it's a lot more complex equipment, and you have a chance to learn a lot more about how equipment behaves. You're working in harsh conditions, equipment that is outside with extremely high temperatures. It's cooled with water. You have dust. So when you start learning about those challenges, you start learning also how equipment behaves and also the conditions that are needed in order for it to function properly. So when I joined Amazon, we started really just working on basic maintenance projects. And when we started visiting a lot of sites, my managers at the time realized, okay, there we might put him on more complex, I would say, programs or projects. And that's how we started working more on predictive maintenance because you have at least a bit of understanding of condition before you start doing condition-based monitoring. So that's how I started in that route. And since then, this has been almost 6, 8 years now that I've been doing this. It's been a fun project. It's been fun times.
Yeah, that's awesome. And like you said, if you can do that work on the complex equipment in those super harsh environments, then it really makes the normal maintenance in a warehouse or a regular manufacturing environment. It just makes it so much easier. There's so many less variables to worry about: dust buildup, dirty,
Yep.
like you said, extreme temperatures, whether they be hot or cold. So, you want to talk about what some of the most common issues are around maintenance strategies, reliability, and maintenance engineering?
Yeah, I'll actually continue on what you just said to I would say answer this question. We're not when we say this, you and I, we're not disparaging like MAT.
Right.
We're
Yeah,
just
not at
saying
all.
that the problems are different. And when you look, for instance, at logistics or MEG, like material handling equipment, the challenge is not the complexity of the equipment; it's actually the quantity. And so you realize that actually you might have really low complex gearboxes, conveyance, machinery in general, but you have 3,000 of them and you still have usually the same amount of people and you need to manage that. So not only you have challenges that are related to that, and I'll actually share what we had in Amazon at the same time, but you start also become forced to use tools that allow you to automate the kind of monitoring that you do because you can't just have someone walking around all day taking measurements on 3,000 conveyors a day, which is just becomes crazy. So going back to Amazon, when you look at Amazon, there's always that obsession with with customer. I would say more like customer obsession, which is you want your customer to be extremely satisfied. And so when I joined Amazon, it was before the COVID, and then COVID happened. Company was just booming, growing, multiple FCs built a year, and it comes with its challenges. The first one is, as we say, we start having rapid growth. That means that you're building multiple sites a year, and what that means also is that well, you start having those infant failure issues. You're not sure, even with the best practices, because Amazon really has high standards, but even with that, you might have misses on machine assembly, on parts that start failing a bit earlier. We had a lot of procurement issues at the time. Remember the COVID period. And so you start having earlier liability issues. Then you have also a challenge where, and this is also something that the people will recognize everywhere, it's really difficult to hire people. It's really difficult to then keep those people that you hire for a long time. So as you mentioned here, you have training issues because you have turnover, and not because people are not happy with it. It's just because it's challenging to keep a certain amount of people, especially when you're launching new sites everywhere. So you start having those issues. And then as you said, it's not only about manufacturing sites, it's also about developing new technologies. When you work in logistics, because that's mainly what Amazon.com, for instance, does, we're not talking about AWS, we'll talk about it a bit later, but you have to stay in front of all your competitors. So you have to develop and create new products continuously. And Amazon is really good at doing that. But that also comes when you create a new product, then you will have new reliability issues. It's not proven, it's not fully reliable yet. So all of that will push you to say, I need tools that allow me to see these issues and to be able to recognize them, know that they will create a change in condition that will not be good for my customer, plan my maintenance in advance, do the repair without impact on my customer. And again, to really insist on that, the customer obsession in Amazon is not just staying. It really is embedded in the culture of the company and the people that work in there. And so we really make sure that equipment has to run all the time because any stop of the equipment might mean an impact on the customer. And we will do everything in our power to make sure that doesn't happen. So, in order for us not to have a machine stop, we need to be able to find beforehand if there's an issue and be able to act on it. So, that's where you start moving to condition based monitoring, condition based maintenance, and you go up of that slide that we just saw earlier in your predictive maintenance strategy until you get to the highest levels.
Yeah, that's amazing. And I love the background of the customer obsession that Amazon has and how it's really built into the culture and
Absolutely.
really drives. That's almost where Amazon starts and then works backwards from there, where a lot of other companies solve a problem and then try and make it fit the customer. And it's not always the best approach. So, can you talk about some of the solutions that you tried while talking or while learning how to keep that equipment up and running and really build that condition-based monitoring as you moved up that triangle?
Oh, absolutely. And I think that this slide is really great about it because it shows you, I would say, the base thinking of the technology that you'll choose. So when we talk about the PF curve, again, for those who don't know, PF curve is what is mostly used by the reliability engineers to define what kind of technology you would use, depending on how early a failure happens in your equipment, to detect that failure and to take an action on it. So you have your performance on the vertical axis, and then the horizontal axis is your time. And so what happens is when failure starts happening, you gradually start losing your performance, and that failure will show symptoms that will be gradually more visible, more hearable, more you can touch them easier, you can see them easier. And so, but what that also means is that your wear and tear on that equipment is getting bigger and bigger until a point where, first of all, it might be irreparable and you have to replace the part. But it also means that you might have the failure and you might have the impact on your customer at the end, after a certain time. And so when we look at the PF curve, for instance, we live and breathe the PF curve, you and I. But
Right.
when we look at it, we know what equipment allow us to find the issues a lot earlier. You have all analysis, you have ultrasound, you have vibration, thermal imaging, and then as you move further into the PF curve, you get to a point where it's reactive. There's audible noise. You can just touch and feel that it's super hot. You can see the mechanical looseness, all of that stuff. But that moment that you're very close to catastrophic failure, you start running around. We call it being a firefighter, and you're just trying to work with your production team to fix the issue as fast as possible. So the second part of it is even when you start doing predictive maintenance at the time, and I think it's really important to put the time related to that. We started in 2020 launching globally predictive maintenance in Amazon. And so for us, we started with handheld tools because one, we wanted people to have ownership of those products and we wanted to change the mindset of our technicians to start using those tools more frequently in their daily life as maintenance technicians. So not only to do a bit of condition-based monitoring, taking measurements, but also thinking, oh, I'm called for an issue right now. In order for me to troubleshoot it, I will use my ultrasound gun, my vibration tool, I will use my thermal imaging camera, etc. And so that's how we started the first years. Once we had that, and again, I can link it also to what we said earlier, high turnover. You have the training issues. All of that was also to, again, to create that ownership. And then we started automating our process for multiple reasons. The first one is because we saw that you improve your quality. So if you do Lean Six Sigma, you realize that repeatability and reproducibility are quite important when you're trying to, I would say, do a proper measurement or just do a proper process. So having someone taking measurement and sometimes not taking the proper measurements can be challenging, but it's also not an added value. We have highly trained, highly experienced technicians. We want them to do highly added value work. So taking a measurement is not really high added value work. So you can replace it with a sensor. And then in addition to that, you can automate some parts of the analysis to help your technician focus again on high added value work. So we started switching to sensors. So for instance, we did vibration sensors. We used the MSAI thermal cameras. We had a full project that is called RIC, remote infrared cameras or checks, and that allows us actually to monitor not only the belts, but also all of our MHE equipment in general. It's a lifesaver because you can see a lot of issues. But that's how we started gradually moving to automating some of that work and allowing our people to really focus one on doing the high added value work, yes, but also launching new projects. Peter and myself were visiting some of the sites last time. We realized, oh, there are new sensors that we can also implement and move even forward in our condition based monitoring journey. And I think we'll get to that point of multiple technologies in a minute, but that's how you start growing in that journey. I hope
Yeah.
I answered your question.
Yeah, that was wonderful. Great explanation of the PDF curve. Like you said, that's we something that we live every day. Most maintenance people probably are at least aware of it and some of that. And then I love that you pulled out the almost a life hack of you. You cannot mandate that the maintenance people just start doing predictive maintenance. It's a culture change. You talked about
Absolutely.
providing them with the tools so that they had ownership to start changing that culture, and then you're able to tweak it long term by automating some of it and just helping those people, those maintenance people, provide more value to the company by automating just repetitive tasks that their people typically aren't good at, just doing the same thing over and over again. So it's like you said, that culture shift and just moving the whole company, the whole culture in that direction. That's
Absolutely.
amazing. So, and you mentioned a little bit about the efficiency and how you have to be obsessed with that efficiency in order to get the throughput, like
Oh,
specifically like at Amazon. So how did that change how you think about like your RME strategy or your
well,
CDM strategy? Yeah.
it's a really good point about efficiency. So one thing that I said earlier, for instance, is when we started this journey, it was around 2020. But period, when you think about it, it was 5 years ago already, and technology has significantly evolved since then. So you have that part, but then if you talk really about efficiency in general for Amazon, there are a few things. People who know Amazon will know what we call the Amazon flywheel. For those people who don't know, the Amazon flywheel was one of the first, I would say, ideas or tenants that was created by Jeff Bezos at the time to manage Amazon. And the flywheel is very simple. It says we want to have a selection of products that we make available for our customers. We also want that selection allows the customer to have a good experience, the biggest selection of products possible. That was again something that Jeff Bezos always said, so that the customer can have one area where he can find the products that he's always looking for. And again, I don't have to publicize that too much because you go to Amazon, people know that now. It's very clear. So that customer experience actually will create a lot of traffic, and the traffic will bring even more sellers. So the sellers will get again more selection, and you have that virtuous flywheel that happens. Next to that as well, you want to reduce your costs of infrastructure, and at that moment you want to lower prices, and again improve the experience of your customer. So that's where efficiency comes in. An example that I can give you, for instance, during my time at Amazon, we had to reduce the amount of downtime we had for maintenance every single year. So every single year is just saying an example, but it would be divided by two, by three. And you say, challenge yourself, find a technology, we will invest in that because we need to make sure that our equipment runs all the time and we need to reduce our cost of maintenance so we can give more opportunity to our customer, like better experience, again, more traffic, etc. And so this is also where you see that Amazon has been following the same philosophy for 25 years and it's been working perfectly. But that's where the efficiency came in. And for us maintenance people, it was perfect because that's also what you want. We'll get to the logic of Industry 4.0 in a second, but our goal was to say, we want to implement condition-based monitoring and maintenance to only do maintenance when it's needed, use only and store the parts, for instance, that you need when you need them, and optimize as much as possible the use of your equipment so that the end customer is satisfied. And that we bring always any work that we do to the end customer at the end.
Yeah.
So
I love that. Oh, sorry. Go ahead.
I just wanted to add one thing. For us, what happened is the way we changed it is again, we moved to sensors that collect automatically data and we started implementing a lot more AIML. We don't say it for the fun of saying it. Using machine learning models allow you to optimize that learning period that was usually done by a human, but also allows us to start optimizing a lot of the processes of data analysis, the administrative parts, where we start to optimize that part. It helps us then have more insight about how machines behave, improve also their process, and then you can go even further where you can start improving your machine overall to increase its life cycle.
Yeah, that's amazing. Thank you so much for going into that. And it's talked about the technology getting better, and that's a great transition into the Industry 4.0. I know you're an expert in the condition-based monitoring and predictive maintenance. We both know from our background. I remember, like I largely did infrastructure. A lot of it was underground infrastructure, so buried sewer pipes, buried steam lines, chilled lines, water lines, whatever it may be, sewer systems. And it was, if we were using infrared or ground penetrating radar or whatever it was, but if we found an issue, a leak essentially, and they were going to dig that up, when you start getting rid of those soils from those heavy industrial environments, it's a very messy process, and you want to make sure that you are, if you say that there's a problem there and they dig it up and there's not, that's going to be way worse than, yeah. So we always used multiple technologies to verify. Well, I was used to joke, if I have one technology that says that there's a problem there, I might be 75% confident. But if I have a second technology that works on a different principle of physics, then I'm going to be 95% confident. So it really cuts down on those angry customers yelling at you from dry holes. So can you talk about the advantages of combining multiple technologies and how that's impacted your career?
I think, first of all, I think you gave great examples of it. I think, as we say, maintenance is sometimes an ungrateful job where you know, as an expert, for instance, that there is something going on with the equipment, but it's not just about that. You have to show the operational people that there is something happening. And as you said, you need to be sure of yourself because that is an impact on your end customer. Regardless if that end customer is, you just want to be sure. So when you do condition-based monitoring, the way to do that is you also need a lot of data points to be sure that your condition is changing. When we saw earlier PF curve, we spoke about vibration, oil analysis, etc. All of these different technologies help you see a different pattern or different information about your equipment. If you look at vibration, it can be great for rotating equipment, for instance, where you can see if something is happening on the gearbox, on the gears, if something is happening, for instance, with a motor or a roller, something like that, because you can see with various levels, I would say, of precision, what's happening with your equipment. The oil analysis will at that moment tell you which component is failing. So that also will tell you, okay, where it might be coming from the bearing, etc. The thermal imaging at that moment, where it might be interesting, it gives you an insight on other components that vibration usually can't monitor. If we're talking about MHE, builds are amazing because you can see if there's over tensioning or under tensioning. And so when you combine all of that, you can be quite sure, for instance, what's happening with your equipment, what the root cause might be, and also where really that issue is happening. This slide that you're showing is a great example. If we look at that build that is right now in this slide, you can see usually just visually automatically exactly what's happening with that build. And what I love about it is you don't have to be an expert to look at colors. Even if you're colorblind, we can still show you in grayscale what's happening with the build. And I know there's an example that you and I said all the time. It's a doctor, for instance, usually doesn't take a decision on one data set. So if you're going to a doctor, he's not just going to put a thermometer up your mouth and say, oh, you have fever, it's cancer. No, he will run multitude of tests and he will analyze a lot of symptoms and make sure that there are a lot of markers available in order for him to make a decision because your life is important. In industry, same thing, the impact on the end customer and the impact on the company in general is important. So combining multiple sources of data help you make that decision. Some of them might be early detection, some of them might be late detection. When you start doing that as well, what you start realizing is, oh, actually, I can see exactly what's happening with my equipment, and I can see if it's going to fail in an average very close to when it could fail. So that starts allowing you also to start planning your maintenance downtime and schedules, planning your resources for your stores. So we'll get to that in a second about the advantages of all of this. But it just brings a lot more confidence to the maintenance teams to work in a focused way on their job.
Yeah, that's great. And like you say, you nailed it with the doctor example. You're not, like you say, you're not going to put a thermometer in your mouth and, oh, you've got cancer. You need the multiple data points for multiple different technologies that are providing data to back up that cancer diagnosis. Yeah, so that's great. So then let's talk, or let's jump into some examples, because not all equipment needs the same combination of sensors. Like you mentioned, vibration specifically is great for rotating equipment, right? Like motors and gearboxes and bearings for pulleys, things like that. Can you talk about some of those different examples and how we pick and choose what sensors go where? Or
Oh yeah, absolutely. So we said it earlier. You said some examples. I said some examples. In the process of solving these kind of issues, what we always say is this: start from the problem and then work backwards. Again, Amazon has great philosophies in that is start from the customer, work backwards. As a maintenance person, your customer can be also your equipment. And so what issues am I trying to solve? If we were talking in the, for instance, a large scale implementation, you want to move your plant and your team towards predictive maintenance. Between brackets, what I would say is, you mentioned it earlier, is like moving to predictive maintenance is a philosophy. So you really want to make sure that you're moving towards that. And the way to do it is, okay, what are the most common problems that we have? What are the equipments that have those issues? Okay, what are those issues? These are, for instance, the type of failures that we have. And you will say, what kind of technology would allow me to detect these failures beforehand in order for me to see them and to be able to fix them again before they break down. So if we're talking about, again, rotating equipment, regardless of the industry, it can be HVAC, for instance, it can be a big gearbox, it can be, because heavy industry at the end of the day, it's either rotating or linear, regardless of the industry. MHE, it's going to be belts, oil, that is a motor, gearbox, and rollers. And so when we look at that, we might say, okay, rotating equipment, I will use, for instance, a vibration sensor that will allow me to collect data, and I can talk later about the data analysis part. We'll get to it. I can use thermal imaging to see my belts or to see areas in my equipment where the overheating is happening. And again, that's like the best couple of technologies that we usually use in the industry: vibration and temperature and thermal, because it just makes your life so much easier and almost covers 90% of the issues. If we talk in electrical cabinets, because those are also a lot of critical equipment, thermal cameras in those electrical cabinets can be perfectly reliable and show you 90% of the issues. Add current monitoring with that, and you've covered most of your failures. If we're talking about HVAC, then for instance, you might say vibration can be good. If you're talking about compressors or transformers, then all analysis might be great. Usually start with, what issue am I trying to solve? And so here you can see it as an example. We see we're talking really about problems and how we detect them. So what are the failure modes? What am I trying to solve? What technology do I use and how do I adapt it? And you don't have to use 20,000 technologies. For condition-based monitoring, usually you can cover 99% of your problems with 4 to 5 technologies. And I'm really talking about covering all your plans, regardless of what you're doing. Doesn't matter. So that's how I would start it, because it just allows you from the very beginning to know exactly what steps you're following. You don't have to choose the technology to solve a problem. You usually do the opposite.
Yeah, that's awesome. And I feel like we've got that theme going where we're starting with what is most important, whether it be the customer or what my problem actually is, and then working backwards from there versus just throwing technology at the wall and hoping that you luck into finding something.
Absolutely.
Yeah, so a wonderful breakdown. So let's talk a little bit about continuous monitoring solutions and just how they play in and how they've evolved. You've mentioned technology since COVID, just even in the last 5 years, and I
Also,
can't believe it's 5 years since COVID already. Yeah, seems like just yesterday. But yeah, so can you talk a little bit about how it's changed over the last 5 years and the things that were it's easily capable of today?
oh yes. So 5 years ago, doing wireless sensors, for instance, was something that was still very new. You had a lot of issues with battery consumption and battery life, and you also, that created a lot of limitation with the type of monitoring that you can do, with the level of precisions that you can have, but also transmitting data, being able to implement that. Again, you were going into a market where that was something completely new. Today, just 5 years after, the new chipsets that we have allow you to do a lot of monitoring for a very long period of time without worrying about battery. The technology evolved to give you the possibility to replace your battery. You can be a lot more precise. It's not really shocking to people. And there was also, I would say, a culture change. And I think you and I speak about it a lot, is a lot of our job is educating our customers about what technology is, what solving an issue is. You don't need, I always joke about it, but I say, you don't need a Ferrari to plow field. You can have just the proper sensor to solve your problem, which brings us back again to what we just said earlier. And you can have the proper equipment working. So when we talk right now today about sensors, it's not about just finding a sensors and making it wireless and that's it. It's about, how can I have, I would say, standardized tool that allows me to collect data from multiple sensors from multiple brands. So you start moving towards something a bit more agnostic, something that makes your life a bit easier. Collect that data automatically. We spoke earlier about repeatability and reproducibility, sending it to one platform that could allow you to analyze that data and monitoring. So it's not just about analyzing data, but it's also you want systems that read that data, create automatic threshold, give you insight about something that's happening. You don't need someone to analyze that data all the time. And then automatically create work orders, etc. We'll talk about integrations after. But that's how, for me, the technology evolved today. So people are not talking about sensors anymore. They're now talking about getting the data in one area, trying to optimize that pricing. So trying to find a partner that is between brackets agnostic, where you say, look, I'm open to taking data from multiple sources, applying the inside of it, machine learning, AI, ML in general, as we call it, Gen AI as well, and then giving you that information so you can make the decision extremely fast.
Yeah, that's amazing. And like you said, being able to take in the multiple different sensor types that are available and getting them all in one platform so that all your
Yep.
data is in one location, it makes it easier for you to see the data from the different sensors and actually see the whole story versus just bits and pieces and then you
Yeah.
trying to meld it together yourself. Yeah. So
One One example that I always cite is the evolution of chargers, for instance, or communication ways for technology. You will always have at the very beginning big companies that will fight to say, I want to impose my standard. Remember the DVD versus Blu-ray and all of that stuff. Today, what companies are wanting, because they have the leverage to do that, is what I call something like the USB-C. Today, USB-C is used pretty much internationally. Even Apple had to fold and use it as well. And that's what companies are wanting. They don't want one sensor with its gateway, with its platform, and you have 20 of them. That you can never use those because it comes back to change management, and you can't ask technicians, humans, to every day look at 20 different screens because those 20 companies don't want to work. So the market is pushing, and the only companies that will survive are companies that are saying, look, I'll take all the data that you have because I can bring the insight. I have the expertise to combine all of them and give you that information. Like here we have our MSA platform. That's pretty much what we do for the customers.
yeah, that's awesome. And great example with the USB-C, how important that open platform is and open source information so that, like you said, you can pull that data in and manipulate it any way you need versus it being gate kept by a company that wants to maintain control.
Well,
So it's really kind of power to the reliability of maintenance engineers, and I love that.
absolutely.
So let's switch gears here a little bit because it's wonderful to have all of this knowledge. Hopefully, the people in our audience have experience, and hopefully, this isn't all brand new information. Hopefully, they have some of it. But even if you have all this knowledge, everybody still has a boss, so they're going to have to go sell it to their boss. And return on investment is a big thing. Companies want to see that they're getting dollars back whenever they spend money on technology, on improving processes, and things like that. So, can you walk us through some ROI sources from continuous based monitoring?
Absolutely. I think you're absolutely right. First of all, as we said earlier, you want to justify this investment with a return on investment or some improvements. Otherwise, everyone wants to buy the most expensive thing and have fun with it. But as we said, you don't need a Ferrari to plow a field. You can just use the proper equipment. I'll go back to the basics that I said earlier. If I want to start with predictive maintenance, if I want to justify to the ROI, that to the leadership that there is ROI, always start with what issues do I have and how can I solve them. So if you're in a plan and you want to start your POC, you will try to look for a product that usually, like a machine or an equipment that has a high criticality, because that is important to the end customer and there is ROI in there. You want an equipment that has reliability issues that you can fix. As I always say, you can do a POC on a motor that breaks down every 3 years. What's the point? You're going to wait for 3 years for something to happen. You
Yep.
want something that is making your life a bit difficult so that you're solving all the time, that you know that has recurrent issues that you could
Yep.
detect with condition-based monitoring. It has a certain criticality. So when you do that, what I also always say is like the proof of predictive maintenance is just proving that you can detect failures before they happen. Once you do that, everything else, as we'll talk about the ROI sources right now, is a consequence of that. For instance, that means I found an issue before it happens. I just started avoiding, for instance, downtime to my end customer because I'm able to say, hey, we found this issue. We will plan the maintenance when there's no impact on the customer, like during the weekend or whatever. We will do the fix and move on. Then the other thing is, if I'm able to start knowing multiple weeks, multiple months in advance if an issue is happening on my equipment, then I don't need that many components in the store. That means that I can start optimizing my store in a proper way, in a data-driven way, to only have my minimum required. You don't have to eliminate spots. You can just reduce them to a minimum level and then order them when it's needed. We always say this, but like the average, I would say, correctness of a store is between 20 to 30%. The rest is just a lot of components that you're storing there to take dust that actually wear over time that you don't really use just because we're worried that we might have an issue and we need them. So when you have your proper data, you can start improving that. The other thing is, and I should have said it from the very beginning, is around safety. The less I am touching an equipment, the I would say the more safe I am. And so if I'm not going to an equipment every single time to fix it, especially when it's done in an urgent way, because you're doing the firefighter mode, then I'm reducing significantly the risk of failure. You cited their insurance. We come from heavy industry. You worked in gas and oil. I work in steel industry. We know what the consequence of a leaky gearbox or something like that could be from an insurance point of view. Same thing for electrical cabinets, as we were mentioning them earlier, because those are a big issue in that front. So the other thing that you start doing as well is you start optimizing your maintenance downtimes because you start saying, I don't need to block my machine 20 hours a month or something like that to do preventive maintenance. I know the condition of my machine. So I know that at the end of the month, I don't need to replace anything because the condition is still good. I can push my maintenance a bit further. So at that moment, when you get to condition-based maintenance, you start saying to your production, you have your machine 100% of the time. When we see a condition change, we will tell you weeks in advance, months in advance that we need it for a certain time. And that will allow us at that moment to get the machine. So production has a lot more hours to manufacture with the same people, same machine, with less investment. That also allows you to run just with more efficient teams and maintenance. Because as I said, they're doing high added value work instead of just running around fixing stuff or doing less added value work like greasing bearings or whatever. So all of these things are a consequence of being able to find an issue before it happens. So then from a production perspective, you said it, you improve your production with the same thing and you reduce your waste or your issues just because that condition from machine allows you also to know something is happening on your production level. There, the condition-based monitoring is not limited to maintenance. It can absolutely and should be expanded to production and supply chain. It's the same data set that you use. It's just you're monitoring full 24/7 instead of monitoring, for instance, every hour. That's the only difference.
Yeah, that's awesome. Thank you for running through that. You
Mhm.
nailed all of those different ROI sources and helping people prove out their case. So we've talked about a little bit of background where equipment falls. 60% of equipment is run to fail. We talked about looking at your failure modes and diagnosing your problems and working backwards from there in order to know what technologies you would want to implement. We just
Yeah.
covered the ROI. So now they've been able, your reliability and maintenance team has been able to go to the manager, CFO, COO, whoever, and get some budget maybe. So let's talk about how they would go then to integrate. I feel like that'll close the loop. Like I said, how do you integrate all of this, or what's a common approach in CBM and RME for integrating these different sensors and starting to do condition-based monitoring?
Yeah. Regardless if it's, for instance, CBM, condition-based monitoring or RME, so that's how we call the teams in Amazon, reliability maintenance engineering. The way, if we go back to what we said a bit earlier, if I look at our slide here and we see like the sites section, this is where we spoke about trying to work with one partner, for instance, that allows you to have multiple sensors, be agnostic, collect data, analyze it, and give you insight. So, for instance, the cloud portion that we see in the slide is the MSI Connect, where here we have that data, it's analyzed, and I'm having insight. So already in your standardization, you're trying to make your life easier, saying, I have one communication protocol that I use, I have one platform, I have my insights. Now, how can I leverage that insight to really be efficient? Again, staying with the Industry 4.0 philosophy, which is optimizing as much as possible the usage of your people, the usage of your machine, the usage of your store. That's Industry 4.0 in general. What we like you and I tell to our customers is try to dilute this data as much as possible in your existing systems. When you do change management, you want to reduce that change management as much as possible. I'm thinking of technicians of all ages and all levels, regardless if you're a super experienced technician but you're not really great with technology, or you're a young technician that doesn't really have a lot of experience but you're good with technology. You don't want to add to a person 3 4 different screens to look at every day, because at that moment they end up doing office work instead of really doing technician work. So when we say dilute this in your existing systems, we want to say if you're already using systems, just add that information in there. If they're using a BI system, regardless of where it is, Tableau, Grafana, Power BI, it doesn't matter. You want to add that data in there and say, yep, we have our platform. If you don't have anything, you can use it. But if you already have your BI, we'll integrate into that. You're already managing your maintenance today with a CMMS or another type of system. If you have an API, we can also send that data and automatically create work orders in your existing maintenance system. We do that for Amazon as well, that use N4. We automatically generate work orders for them, so they don't have to look at another platform to see if something is happening. What that means is we make sure at that moment that maintenance is planned, that it follows the requirements and standards of Amazon, but also that all the reporting systems that are used to see how work is progressing as senior manager or as leadership are automatically updated with that data because we integrate it in there. If you're using, for instance, Teams or whatever to communicate, you can integrate with that. But the goal is to say, you're already having a good way of working today. Let us integrate into that and give you that insight. And then, of course, it just gives that flexibility to each customer to say, we'll help you in your journey for Industry 4.0 to add this data and to just leverage as much as possible. Instead of asking them to adapt to your system, we adapt to theirs.
Yeah, that's great. And I think that ties right back into that almost that Amazon mindset of being that customer obsessed. You want to meet the customers
Absolutely.
where they are. You're not trying to bring them to you. You have to build the bridge and go to them. So being integrated in their systems, how they already work, I'm sure they've gone through multiple iterations to get to that process and why they like that process. So being able to
Mm.
just mesh right into that process is huge. And you definitely want to be working with companies that do that.
Oh, yeah.
So that's the presentation that we have today. Thank you again, Marwan, for joining me. This was a
My
great
pleasure. Thank you.
conversation. I really enjoyed it. And I believe Cole may have some questions that were submitted from the attendees. Myself and Marwan will answer those now.
Awesome. Yeah, thanks. Great presentation. We had a good amount of questions come in. So the first question, how long does it take to build up history to a point where one can implement based data decisions?
It's a good point. So it really, this question a lot of times comes from, I would say, the fact that we think that we have to work, I would say, in 20, 30 years ago, 10 years ago, where we were looking, for instance, at absolute measures. And that's because you couldn't have those sensors that were collecting data all the time or continuously. So you had someone that would take absolute measurements and you would compare that. So that takes multiple months to build. Today, with sensor, you can take actually a measurement every hour, every minute, every second. So in an average of 2 to 3 weeks, you can already build data. You don't need a lot of historical data in order to create your threshold and to have already a proper CBM monitoring. So an average of 2 3 weeks is more than enough to create your models, have your thresholds, and already start monitoring. You can start today, as we say. You don't need months of historical data to start your product and have your ROI quickly.
Gotcha. Then what strategies are you using so maintenance teams can quickly troubleshoot and repair the latest cause of downtime?
So for this, I don't like this question too much because, and I'll say why. Yes, again, we have tools that allow us to do that. But the reason why I say I don't like it is it looks like we're saying we're firefighting. How can I be a better firefighter? The whole point of doing condition-based monitoring is to say we are already monitoring our equipment in a continuous manner and we are able to see the change in condition before it happens, like over time, and act on it in a proper way. If we have spot issues, because those can happen, then I would always say try to instill that ownership of using those CBM tools the same way guys will use their other tools, like I would say, I don't know, a multi tool or screwdriver or wherever. They should be able to use their thermal camera, their vibration analysis tool, all analysis, all of those tools that allow them to have more insight about what's happening with the machine. And I'll just to give again more context about this. The reason why we use those tools is they're an extension of our senses, but they allow us to see stuff that our senses can't see. When you look at thermal imaging, it's literally just showing you colors and changes through temperature that you can't feel with your hand. Vibration and ultrasound are literally just us touching or hearing a change in machines, but months, years before they happen. So those tools allow you to do the same troubleshooting, but with a lot more precisions than a human sense can do. So that's why we push out, say, that ownership to the people. But again, the goal is not to be a better firefighter. The goal is not to be a firefighter at all. Not that we have anything against them, but again, you want to optimize. That's the goal of Industry 4.0.
Couldn't have said it better myself.
Thanks, mate.
And what are your recommendations on edge versus cloud data management?
We don't have any, it depends on what you're trying to monitor. There's nothing that is better or worse. For instance, at MSI, we do both. We don't have an issue with that. We have our technology that can run on edge, but we can also ingest data, for instance, from a wireless sensor. The way I would really say that there's a separation is if you're doing, for instance, continuous monitoring, which is like, for instance, for our thermal cameras, we do continuous monitoring, then preferably or usually the only way you have to do it is on edge or on prem, as we say. It's a slight difference between the two of them, but it's just because there's such an amount of data that is collected, analyzed, and processed that if you were to send it to the cloud, the cost of that data processing and sending would be enormous. We go back again to the ROI conversation about how can I use an optimized equipment to solve my problem. When you're doing just predictive maintenance and you're sending spot data from time to time, for vibration we send data every hour, every 2 hours, very low quantities of data, then using full cloud solution might help, because at that moment the cost is very low, it's to a minimum, and you can still do great monitoring. So it also can come back to what we say: what problem am I trying to solve, what issue am I trying to help my customer with, and that drives your technology. But there's not no technology that is better than the other. Both of them can work to different, I would say, problems that you're trying to solve.
Yeah, I'm going to disagree slightly. I prefer the cloud solution because nothing ever fails at 2 o'clock on a Tuesday. It's always 2 a.m. on a Saturday or a Friday night. So being able to log in and view, have an idea of what's going on without even having to leave your house or your couch or anything like that, especially if you're having to drive to the site that's having the issue, things like that. But like Marwan said, it's really customer driven, how sensitive they are for their data being shared or being on the internet, things like that.
I think you have a good point actually there, because it does push us to say that you can run hybrid solutions. You don't have to, like, it's not a one versus the other. As Damien said, you can have an edge solution that is cloud connected. And so you can have both of them. You can have also both hybrid solutions where there's edge for some sensors and cloud for others. It's not a one versus the other. It can be both. But I do fully agree with what he said. It's a lot easier to access from everywhere you are than trying to run to the plant when you're on vacation. So I do agree with him on that one.
Yeah, that's a good point. And what is the biggest challenge when implementing continuous monitoring sensors?
For me, and this is something that actually is being solved recently with a bit of Gen AI, is the way I say as well is try to eliminate as much administrative work as possible. And the example that I use, maybe unfairly, is in Six Sigma, world class manufacturing, all of these amazing tools that were created in the 70s and the 60s with amazing people, very simple to implement, but they are so administrative that to this day, they're not standardized in companies. You can go to a company that says we do world class manufacturing, but then when you go on the plant, you have actually one machine that is world class manufactured that we show to the leadership, but the rest of the company is kind of running. They're trying to do world class manufacturing, and so when you do condition based monitoring, you end up with those same challenges, which is I'm implementing the sensors that might go fast. Damien and I go with these challenges a lot, which is naming your assets, collecting that data, making sure that you're linking the assets properly, going through that training, creating the SOPs. This is something where I'm pretty confident that in the next 2-3 years is going to be heavily solved with the use of AI/ML, something that we're already doing with our customers, but also the use of Gen AI on the long term, and then just allowing the customer to automatically link his usually misorganized, a bit scrappy data to the new systems and properly visualizing it for him.
Yeah, and just to add on to that, I was going to say just those startup problems that you were talking about. I think I find that when I talk to a lot of customers, they agree with the strategy. They don't want to be firefighters anymore. They actually want to have their day planned out, not just
Yep,
running around trying to fix everything that's falling apart all day long every day.
yep,
So I think that culture shift and getting started is typically what I see as the hardest part. But I think Marwan laid out that great Amazon example where they started with the handhelds and they were doing route based, fairly easy to implement. You may get some bad data like Moran was talking about when you're first starting. It's okay. Everybody always does. Just recognize your
totally.
mistake and figure out how to clean it up with those standard operating procedures and some of those things that he was talking about, the trainings and things like that. So I would say it seems like getting started a lot of times is the hardest part. And if you just take those small steps and just break it down into bite-sized, manageable pieces, then a lot
Yep,
of times that'll set you up for success. And doing something, I think, a lot of times is better than doing nothing. Just continuing to
absolutely.
do what you're doing, taking a step in the right direction is huge.
One thing that I would add to it as well is we talk about this with Damien, but we also do realize that it's easier to said than done. And so, for instance, and a huge portion of our work actually is bringing that experience that we have in launching these huge projects and implementation to our customers. So, for instance, when we work with our customers, it's not like here's the technology we can integrate. Good luck, have a good day. We come in and we say, we'll accompany you from A to Z. We'll help you in choosing what proper sensor. We'll help you in finding how to implement this. We'll do the POC for you, and then when you're satisfied, we'll help you in defining your ROI. We literally help them in every single step of the way. And then the final step is let's sit down, let's plan your 5 year strategy about where you want to get of with this industry 4.0. It can be a C-level person, it can be someone in a plant. Sit down with them, it's like, okay, this is how you're going to go year by year. This is how we will accompany you, and we give them that support. And I think it also just again reminds of that customer obsession. We really are obsessed with making sure that the customer had that best experience from end to end. So again, when we say those things, it's not like we're expecting the customer to have them. We're more than happy, and that's what we do. We accompany them from end to end to make sure that they get to that level.
Awesome. And I know we're at the top of the hour here, but if you guys have time for one more question that came in.
Sure. Absolutely.
So, how is labor resource allocation affected when you switch to condition-based monitoring and response?
So I can give a bit of insight on it. As I said, I actually mentioned that a lot earlier. I'm a maintenance person. Damien is a maintenance person as well. I always said maintenance people are high added value, I would say engineers or people in a site. Even if you go to Amazon, they're the most skilled people that you will have on site. And so if I'm a finance person or CEO or even a maintenance manager, I want my high added value people to do high added value work. And so when we start doing condition based monitoring, our goal is just to eliminate a lot of those, I would say, work streams or workloads that don't bring any added value. I always said, like in the steel industry, I'd rather have a subcontractor grease the bearings and motors and whatever that I have on site, and let my people focus on new predictive maintenance projects, new continuous improvement projects, stuff that they like to do, and also just highly complex repairs, because that's what they're good at. And when you do again predictive maintenance, the goal is to say, I optimize my maintenance downtime so that I can allow my people to do that. We eliminate that firefighting mode. That's one thing. The other thing as well is hiring maintenance people is really, really difficult. And so a lot of times actually companies, it's not about like how can I keep my maintenance people occupied? It's like how can I hire enough maintenance people to just barely do the work that I have? And so that's where condition-based monitoring can help with managing, I would say, full-time employees and workloads to just be optimized and make the people that work in your team very happy to do their job.
Yeah, just to add to that is excellent answer. I was just going to say it goes from that crazy firefighting to actually optimizing their time. So you're getting
Exactly.
more out of them. There's less running from one side of the building to the other, pushing a tool cart, trying to quickly repair the equipment and get it back up and running. It's okay, I can get over there and maintain that equipment when it's down. And then when that other piece of equipment on the other side of the building, if it's scheduled to be down later, I already know what needs to be done for it. So I can go over there and do that versus when it breaks down randomly and then I'm scrambling trying to find the right parts and the right tools and diagnose it at the same time. It just helps everybody be more efficient. I would say it is not a reduction in time at all, like Marwan said. It's optimizing those people's time.
Awesome. Gotcha. Thank you, Tamian. Thank you, Marwan. And thank you all
Yeah.
for joining us today.